Well, here we go. It's time to start this introduction or getting started in Python in Transform 2022. So welcome to everyone, wherever you are. This event, Transform 2022, has already started over the weekend, but today I'm going to be kicking off the tutorials. I'd invite you to all visit transform.softwareunderground.org. You'll find all the information about the various tutorials available to you this week. And everything is also in the schedule, which you can reach by going to the short URL swu.ng/T22 schedule. That again will, if I open this, that will take you to the schedule here, and you'll have links directly to the YouTube channels there. These obviously will be available after the event as well. So without further ado, I just want to get us started. So my name is Rob, and I'm going to be taking you through this getting started with Python tutorial. Just to set the scene, this is really aimed at people with no Python experience whatsoever. And I'm not teaching you Python here. What I'm aiming to do is to just give you some tools and give you some exposure to what you can do with Python and how it works, so that later in the week, or maybe in a month or 2 months, when you look back at some of these tutorials, you'll be able to follow along, really. And then in time, you'll write your own code. Now, if you're watching live and you want to follow along, there'll be links you'll find to this Git repository. I'm not going to explain Git in detail here. Suffice to say that you can find all the material that I'm going to be sharing with you today on this webpage. And if you want to download it, if you navigate to this page, T22 Getting Started, go to the code button, this big green button here. You've got access to a zip file that you can download, and that will include all the data, all the files, all the images that I'm going to use here today. Now, in this tutorial, I will be running through this Intro to Python Live notebook, and I'll illustrate what a notebook is shortly. You're welcome to code along in there if you like. If you're coming to this later and you want to have the answers, as it were, you can have a look in the main notebook, which I won't be showing live, but I'll be referring to during the introduction. Now, I may depart slightly from what you see in main because I'm going to be live coding in this notebook, so there'll no doubt be some differences. A couple of files I want to point you to. First of all is this installation and setup. So this is a file that's written in what's called Markdown, and I'll talk about that briefly. I'm going to go through this, but on a separate tab, using something called Reveal MD, just to look at the slides. But if you want to look at the raw text, you're welcome to look at it here. What else? Yeah, that's about it. So with that, I will get started with the installation and setup. And just try to get us all on the same page. So, as I say, you can follow this on the GitHub Markdown file if you prefer, but otherwise just follow along here. So, what I'm going to do, I'm going to kill my webcam so that hopefully this works smoother. So we'd like to get Python installed on your computer. And let me say straight away, it doesn't matter whether you're on Windows, Mac, or Linux. Python will work on all of them. So the first thing I would suggest is navigate to python.org. Now, you may not want to install from here. I'm going to show you two different ways of installing. But the easiest, I'd say, way to install Python is simply to go here, choose your operating system, Windows, Mac, or whatever, and then download Python and install it just like any other program you would on your operating system. Now, in this particular tutorial, I'm not going to be following this. I'm using something called Miniconda. Now, what is Miniconda? It's a minimal installer for Conda. Now, I realize that's yet more jargon. Conda is a program that allows you to install packages that Python needs, and Miniconda will include that program. So that means you've got Conda, you've got Python, and all the packages that they depend on. So packages is just a word for code. So other code that other people have written that these different languages and programs depend on. So if you want to use Miniconda, I've included links to the installer links over here. So you can come to this page, find your platform, Windows, Mac, or Linux, select the correct 64-bit, most likely, installer, and then just go ahead and install that. So run the installer, accept the license, accept the defaults, and at that point, you've got Miniconda installed. Now, at this point, you won't yet have a full installation that allows you to follow the tutorials this week, but we're going to get to that. Now, another way you could approach this is to use Anaconda. Now, Anaconda includes Python, it includes Conda, just like Miniconda, but it also includes hundreds, if not thousands, of other programs or packages that you might want to use for data science, for machine learning, for visualization, and so on. Now, you might choose Anaconda if you're completely new to Conda or Python, and you like the convenience, basically, of having Python and over 1,500 packages automatically installed at once, which means you don't have to come back and install them again later. You have to have some time and some disk space because it'll take a few minutes, and I think it's about 3 gigs. So on most modern machines, that won't be an issue, but perhaps it is for you. Now, Anaconda is also good if you don't want to individually install each of the packages you want to use. And you basically have access to a set of packages that are curated and vetted for interoperability and usability. So basically, you know that everything is going to work. However, do be careful if you're working for a corporation because there are licenses for Anaconda. If you're a student, if you're doing this as a personal project, that's totally fine. But if you're using Anaconda inside a corporate environment, you'll need to get a license. Now, you might choose Miniconda in contrast, if you don't mind installing each of the packages you want to use, and I'm going to show you a way to do that shortly. If you don't have the time or the disk space to have everything in Anaconda, and you might just not want to have everything, and if you just want fast access to Python. Now, just a brief note on different operating systems. So Python works on Windows, Mac, and Linux, and actually other platforms as well. There's links to that right here if you're interested, but I'm not going to dwell on that. Okay, so why would we need a coding environment? I've talked about packages. I've said that, we get Python, but then we have these other things we need to install. Why can't we just do everything with Python on its own? Well, if we look at this plot as an example, to create this, we've needed to load different types of data. So logs, LAS files for the geoscientists amongst you, some maps, some seismic, and then we're actually plotting them. And in order to do this, we're using some Python code, but that's been written by different people. So we're using libraries called NumPy, Matplotlib, Welly, and each one of these is a collection of Python code, which means you don't need to reinvent the wheel, that allows you to solve a given problem. So NumPy will allow you to solve numeric Python problems, so basically anything to do with mathematics and science. Matplotlib will allow you to make graphs and plots. And here I mentioned Welly. Welly will allow you to load and manipulate log files, LAS files. Now, what we want is we actually want to delegate this dependency management to a program, what's called an environment manager. And I've mentioned one of these already, and that is Conda, because what you do not want to do is to install, for example, NumPy, and then go and look up yourself what other packages NumPy depends on. And so there are tools that allow you to do that. Now, those tools include, amongst others, Conda, which I've talked about and which we'll be using here, PyEnv, VirtualEnv, and many others. Now, in this particular tutorial, we'll be using Conda. And if you go to the documentation there, you see everything you need to manage what's called an environment. Now, an environment is essentially a collection of software at a given date. So if I was to create an environment today in order to make the plot that I just showed you, all the software that I install would be dated 25th of April 2022. Now, if you come to this video in 6 months' time, some of those softwares most likely will have been updated. And so if you create an environment, some of the code might be slightly different. So that's why sometimes you want to manage these environments, and in particular use an environment file that can tell you not only which packages you want, but also which versions you want. That's not always something you want to do, but it's a possibility. Now, I've also linked to Stack Overflow. Now, if you're new to programming, this will be a new website to you, but I'm pretty sure you'll end up on it at some point. It's essentially a questions forum, question and answer forum, and it's one where there's a really good discussion about what the differences are between Conda, PyEnv, and virtualenv. So in Conda, how do we actually set up an environment, as we might want to do for this week's tutorials? Well, the first thing that we're going to do is we're going to download an environment.yaml file. I'm going to click this link just to show you what it is. And if you're on Windows, just leave it in your download folder, and then the following command will just work. If you're on Mac or a Linux environment, just download it wherever you want, and then in your terminal, navigate to that folder before running the command that I'll tell you shortly. But before I do that, I want to show you what we're actually downloading. So this environment.yaml file is just a text file, nothing else. And you can edit it. It does have to follow some indentation. So you can't just write in Word or whatever. You have to write in something that respects the white space. And it has several things in it. We'll revisit this later, but just at this point, I'll say it's got a name. This is going to be the name of the environment. The channels are going to be on Anaconda where you're grabbing the data from, the programs, the Python code. And then it's going to list all your dependencies. And we'll come back to these a little later in this short installation presentation just to talk about what we have. At this point, I just want to say that we're saying a name, a source, and some code that we're downloading. Now, once we have that, again, if you're in Windows, you can run this command all on one line. You'll have to open what's called an Anaconda prompt. Now, on Windows, if you've installed Miniconda or Anaconda, you will have a new program which you can access through your Windows search key called Anaconda prompt. So open that terminal, that prompt, and then in there, type on one line conda env create -f, and then all of this. And you'll, if you're following this from the GitHub Markdown file, you'll be able to just copy paste this command. If you're on a Mac or Linux environment, you won't have an Anaconda prompt. However, if you've installed Miniconda or Anaconda and you follow the default installations, you'll be able to run these conda commands directly from your terminal or your terminal emulator. Now, if you're on Mac or Linux, as I mentioned earlier, just save this environment.yaml file wherever you want, perhaps in your downloads folder, navigate to that downloads folder, and then you simply run conda env create. You don't even need to have -f and all the rest of it, because that will be the default. So at this point, we've created an environment. And as you may have seen up at the top here, it's one of two slides. So our environment is created. What that means is that we've downloaded the packages. But the next thing we need to do is actually make it available to the code or the software that we're going to use later as our coding environment. So to do that, the first thing we need to do is conda activate and then the name of the environment. Remember, the name was found in the environment.yaml file. And all of these commands we're typing in the Anaconda prompt or in your terminal. And the next one, again, all on one line, is going to be Python -m ipy kernel install --user --name followed by the name of the environment. Again, that name that you find in the environment.yaml file. And so what we're doing here is we're using a package in Python called ipy kernel. Inside that package, we're using a function install, and we're passing arguments to it so that we make this, this environment available to the Jupyter Notebook. Now, I realize I've not mentioned Jupyter Notebooks yet. We'll just have to hold that thought for now. We have to run these commands so that we've got access to the environment later on. Now, at this point, we would have just created an environment solely with the things listed inside of this environment.yaml file. So only with these things, which again, I'll explain a little later. But you might want to add things to it. So if you want to add to an existing environment, you need to add a package. So to do that, you first need to activate the environment once again to make sure you're installing only inside of that environment. And then you have two choices. If the package you want is available from Anaconda, you run conda install package name. If, however, the package is not available there, but it's available only on the Python package index, which I can show you. The Python package index is basically a place where there are, as you see, just under 400,000 projects. So these are Python programs that you can install. And you install these programs specifically with pip. So either you use conda to grab something from Anaconda, or you use pip to grab something from the Python package index. And again, pip install package name. So at this point, we basically got our environment and we're essentially ready to start coding. Now, to start coding, following this particular approach, which, as I'll explain shortly, is not the only one, what we would do is run Jupyter Notebook. Now, you would do that from a location on your computer where you have data. So, for example, if you were following along this tutorial, you would have downloaded all these data from the zip file that I mentioned initially. So you would have downloaded this zip file and you would have unzipped, extracted that zip file to some location on your computer. And then in the Anaconda prompt or in the terminal or in Mac and Linux, you would navigate to that location and then you would run Jupyter Notebook. Now, when you do that, you'll see in your terminal or your Anaconda prompt that you start what's called a server. I don't know if this will be visible on YouTube or if it's too small, but basically in your Anaconda prompt / terminal, you start a server and then your computer will open your default browser with the Jupyter Notebook. Now, we're going to look at that in just a second. Well, actually, let me show you what that would be. So if you open that, if you run that, the Jupyter Notebook will open, and if you've opened it from the location where you've downloaded all the data, you'll see something like this. Now, before we look at this, we need to do a couple more things. First, let's have a look at this environment.yaml file to see what we actually installed. So let me go back and open this environment.yaml file. And now let's have a look at what we've got down here. So we've installed Python, of course. We've installed pip because that won't be there by default, and we'll need this to install other packages. Then I already mentioned NumPy and Matplotlib, so these are for numeric Python and plotting. Jupyter, this is our chosen coding environment, and we're going to talk about that next. IPY kernel, we've just used it. This is something we need to make this environment available to Jupyter. And then pandas and OpenPyXL are things that you might need if you're dealing with 2D data sets, spreadsheet-like data sets. OpenPyXL to deal with Excel files in particular. I added requests there. That's simply to make queries on web pages. And then from pip, we're getting packages that are more geoscience focused. So Bruges for geophysical tools, Welly and WellPathPy to deal with well logs and deviations, SegWI.io and SegWI.sac to deal with seismic data, and GIO to deal with file loading of common geoscience and subsurface formats. So this is obviously a bare bones, well, not obviously, but this is a bare bones environment. And if you use this environment in one of the tutorials later this week, you will no doubt need to install additional packages, which the various presenters no doubt will either share with you in another environment file, or simply tell you how to install them with conda or pip. So now we've seen that, let's choose a text editor. So if you want to write code, well, yeah, you need to write it. So what we're using here, or what I'm going to be using, is the Jupyter Notebook. Now, you've seen this image before, and the Jupyter Notebook essentially allows us to share or to combine formatted text, code outputs, images, everything you need to prototype some code. Now, there are some pitfalls to using the Jupyter Notebook, especially for beginners. We'll touch upon them perhaps, but it's not something I think that should stop you from using this. Now, if you want, you can use a more traditional text editor. There are plenty out there. I'm just listing a few here, and there are links if you want to visit them. It's really up to you what you choose. As long as it works for you, it's the correct editor. If you want to be more old school, again, there are plenty other editors out there, all totally valid. And again, it really doesn't matter which one you choose as long as it works for you. So at this point, we've created an environment, we've chosen a text editor, I've picked the Jupyter Notebook, and now we want to run Python. So how do we do that, or how can we do that? Well, we can run Python in multiple ways. We can execute Python code in an interactive session. What does that even mean? Well, it means that inside your terminal or inside your Anaconda prompt, you could just type Python and it would launch that program, and then you can write your code. That's fine for quick testing, for checking features in Python, but obviously that's not where you're going to write scripts that you want to reuse. Scripts are just Python files containing Python code. So you can run a Python script directly from the operating system, and we've actually done that already when we ran Python -m, IPY kernel, etc. There we were running some Python code using Python. And finally, you can use something like the Jupyter Notebook, a Binder instance, Google Colab, any of the others. And again, it really doesn't matter which you choose or you use, it's whatever works for you. So with that, we're ready to go into the actual notebook. So let me close a few things here. Close this. I need to close things on another screen as well. There we go. And now I'm going to go into my Jupyter Notebooks. Remember, we've started this. And as I mentioned, in this live YouTube presentation, I'll be coding in this Intro to Python T22 Live. That's the one I've got open right here. So first, let me give you a quick tour of the Jupyter Notebook. So as you see, it opens in a web browser, whatever your favorite browser is, it doesn't matter. I would say that some things, and in fact, some things I'm going to show in this demo will not work in Internet Explorer. But if you're on Edge, Safari, Chrome, or any Chrome-based browser, you're basically good to go. Firefox as well. So in the Jupyter Notebook, there's a few things that are good to check when you launch it. First of all, up here on the right, you see the name of our environment. And so straight away, I'm going to show you that if I go to kernel and change kernel, down here, I see T22 setup. Now, that is the kernel or the code collection, the environment that we're going to be using in this demo. And I would not have had this available to me here had I not run that command Python -m IPY kernel install, etc., etc. So that's why we needed that. Then we have standards, file open, rename, copy, etc. Editing, we'll talk about that because I need to explain what cells are. Things about viewing, inserting. The kernel, I've touched on this. Basically, the kernel is the Python code running in the background and executing your code. And so sometimes that program might freeze or break, and so sometimes you'll need to restart it. But in general, they're pretty stable. Then if I click over here, you see that this first cell gets highlighted in blue. And as long as I'm in blue, if I use my up and down arrows, I can navigate up and down in the notebook. If I hit enter, the cell outline turns to green. And now if I use the up and down arrows, I'm inside that cell and I'm editing that cell. If I want to go back to blue, I can hit escape and then I can navigate, but you notice that the the cell is no longer displaying as it was. So to do that, what I do is I hit Shift Enter and that executes the cell. So you can navigate, or you can switch between editing and navigating with Enter and Escape. And once you're happy with a cell, you can execute it with Shift Enter. There are other things you can do as well, but I don't want to just say everything at once. So there are plenty of shortcuts, and I'll use perhaps a few in here. If you want access to the shortcuts, you can go to Help, Keyboard Shortcuts, and that will list all the inbuilt shortcuts. You can actually edit them to write your own if you prefer. I'll be using things like A to insert a cell above, B to insert a cell below, DD to delete a cell, things like that. I'll try to tell you what I'm doing every time I'm doing it, but in case, it's all there. Now, we can have formatted text, and if I double click, I can show you, first of all, here we've got a title with a single hashtag. Here we've got a subtitle with 3 hashtags. We've got a list with these ticks. And here we've got hyperlinks. So you can pass a hyperlink with square brackets and the name you want to have, and then parentheses and the actual target. So if I do this, we'll see that we've got links to the original Markdown file, or the original Markdown page, where John Gruber explains what he wrote here. You've got links to getting started in Markdown and the cheat sheet as well. And I invite you to go and visit those links if you're new to Markdown. Very quickly, so if I double click this cell, I can go into edit mode as well. So an H4 heading, here we've got unordered lists. So basically just a bunch of dashes, and we can obviously indent them to have sub-items. An ordered list will be numbers, and then we can have all the usual things: italic, bold, underline. So I've put underline here. This is not strictly Markdown, but this works in the notebook. You can have quoted text. So let me show you what that is. So quoted text will appear like this. And you can have tables. And again, don't remember stuff you can look up quickly. Just go and grab it from somewhere else and modify it to match your needs. So that's formatted text. Now we can have mathematical equations as well. You can write LaTeX. So if you're not familiar with LaTeX, I've given you a link there to it. So here we've got an inline equation, and here we've got a centered equation. And the way you do that with the inline equation, you simply write your LaTeX code between $signs. And if you want to center it, you have $2 at the start and the end. For the actual syntax to write these equations, I'd invite you to basically visit the LaTeX documentation. We can also have code, so code inline like this, or multi-line code. And the way we do this is we use backticks for inline code. So backticks, well, I don't know what keyboard you're on, but they're not quotes or double quotes. They're a special character. And if you have 3 backticks and you give the name Python, you can actually format Python code, or write Python code, and it will be rendered with the correct syntax highlighting in the Jupyter notebook. So next, what we can do is we can actually have code output. So here I've got some Python code, perfectly valid. And if I run this, you see that I get an in1. So this cell has been executed, the code has been executed. And the output of this function print simply gives back to me whatever was inside my quotes here. So hello, transform 2022. So here we go. We've got formatted text, we've got inline code, we've got formatted code, and now we've got code output. And finally, we can actually have images as well. So here I've got a link to an image which is stored inside of this same folder, in the images folder. And if I execute this cell, you see that image is rendered in my notebook. So hopefully there you see that with a Jupyter Notebook, you can actually document your work really well. And I think at least several of the tutors this week will use Jupyter Notebook or perhaps Jupyter Lab. So you'll most likely see this kind of thing used this week. Now with that, I want to move into Python and actually show you some Python code. We'll start with things that you most likely already know, even if you've not seen them in Python. And here I'm using keyboard shortcuts A and B to add cells below. So what we'll start with is simple addition. Nothing strange going on here. I'm putting spaces around the operator. That's Python syntax. It will work without the spaces, but you really ought to use them. So all the usual things that you'll expect, plus, minus, let's see, multiplication, that all works. Every time I'm executing the cell with Shift Enter. Let's see, division, so 11 divided by 2. Here we see something slightly different. So the operator is not strange or anything, but now we see that we're getting back a floating point answer, which we expect from 11 divided by 2. So in Python, you will get back the most expected result. So 11 divided by 2 won't give you 5 remainder 1, it will give you 5.5. Now, similarly, if I do multiplication, I don't know, 45 times 0.4, I get back with multiplication. If I use a float or a value with a decimal value, a number with a decimal value, I will get back a float as well, even if that is something .0. I'm not going to get back the integer 18. I'll get back the float 18.0. Now, if I come back to this example here, 11 divided by 2, sometimes you may want to have the long division or the integer division, and that's available to you in Python if you pass 2 forward slashes. So that will return 5. And then if you want the remainder of this division, you need to use what's called the modulo operator. And so the modulo operator is the percent symbol, and that will return to you the remainder of the long division. So addition, subtraction, multiplication, division and long division, and the modulo operator. I'd wager that apart from the long division and modulo, all of that's pretty familiar. Now, the next thing I want to show you is exponentiation. And in Python, we do exponentiation with two stars. Generally, you won't see spaces around them, but again, it'll work with or without. So there you go, exponentiation. Now, there are more, but again, this is really just a quick intro. I don't want to dwell on all the intricacies that you might see. I do want to mention logical operators. So again, I'm going to use B and A to add a few cells here. And so logical operators are things you've seen before. So greater than, for example, 23 is greater than 4. And so that returns to me what's called a Boolean. And in Python, Booleans are true and false with a capital T and capital F. So likewise, if I say, I don't know, 543 is smaller than 1,000 or smaller than 10, that's going to be false, right? 543 is greater than 10. So no surprises there, hopefully. Now you also have greater than or equal. So if I do, I don't know, 200 is greater or equal to 199, that's true. And likewise, I can do 200 is smaller or equal to 199, and that will be false. So greater than, smaller than, greater or equal, smaller or equal. Now, if I want to check for equality, for mathematical equality, I could say 32 is equal to 32 with 2 equal symbols. That is true. If I want to check for inequality, if I say, for example, 32 is not equal to 42, that is also true. So not equal is with the exclamation mark equal symbol. Now we can combine these. So for example, I can say 11 modulo 2. Remember, that gives me 1. Well, I can say this is equal to 0. That's going to be false. So here I'm getting an expression, and then I'm getting the result of that expression and doing a Boolean comparison to a value. But if I wanted to, I can combine these. So for example, in parentheses, I could say 4 is greater than 2. And in parentheses, 50 is small or equal to 10. And so this is false because one of them is false. If I wanted to use or, well, I can do the same thing actually. I can copy this and change that to an or, and that is true because one of these two is correct. So 4 is greater than 2, and therefore this is true. However, 50 is not small or equal to 10, so this top one is false. Okay, now assignment. Here I've got something already written. I'm saying x is equal to 10, and remember that mathematical equality is 2 equal symbols, not a single one. So if I say x equals 10, first of all, if I run this, I get no output. Hopefully you'll have noticed that every cell so far, we had an in and an out, in and out. With the assignment, people often say assignment is silent in Python, and that means that if there are no errors during assignment, you get no output. However, now if I look at x, and here I've got an output, x holds the value, or points to the value 10. So hopefully everything so far, even though you may not have written Python, is not too surprising. And hopefully you actually know a lot of this already from mathematics at school. So now we're going to step sideways a little bit and look at different words and collections in Python. So there are different ways to hold data in Python. The first one, well, actually we've seen integers, floats, and bools already. But here we're going to look at strings. So if I have a word, and this is just a name, it could be anything you want, and I assign that to a value, and I'm going to say the word is Python. You notice that word as a name has no quotes. So that's like a variable in a mathematical equation. You say, let A hold the value of 42 or whatever. So that would be my A. And then Python in quotes, that's the actual value being held. So if I run this cell now, I'm asking for the type of word, and the type is string, str. Now, if I look at word, I get back Python. So indeed, word is holding the value Python. Now, here I'm using single quotes. Let me just illustrate. If I was to do double quotes and I say, this is actually the same thing. And if I look at double quotes, you see that I get back, or Python shows me my object again with single quotes. So it doesn't matter which you use, and you'll see both used. Simply, they have to be consistent. So you can't mix them. However, the reason we have both is that it allows you to put different types of things inside of text. So you might have, for example, something like this, where you say, hello, y'all. And this only works because I've got double quotes on the outside, because otherwise with a single quote here, if I had, let me show you, oh, sorry. If I had single quotes on the outside, I would get an error. And immediately you see that the syntax highlighting is showing me this in red and then this in green. If I run this, we get a syntax error, because Python is reading this string, and when it gets to the end of it, it stops and it doesn't understand what you're doing here. So to sidestep this, you can use double quotes and single quotes. Errors in Python are generally very helpful, and so this is one that's very short. They can be much longer, but if you get an error in Python, always look at the very last line. It'll tell you the type of error that you're dealing with, and sometimes it'll actually show you where the error occurred, so you can go back and look in your code and hopefully fix it. Okay, now strings have got different attributes. One of them is you can pass them to the function len, and it will tell you how many characters are in that string. And you also have string methods. So again, I'm adding a few cells down here. So for example, I might say words.upper, and here I'm using a new syntax. I'm saying word, that's my object, and then dot, and then a function, and I've got parentheses after that function because I'm using that function. I want to execute that function. And the jargon for that is to call the function. So if I call the function upper on the object word, I get back Python in uppercase. However, in the Jupyter Notebook, if you put your mouse or your cursor inside of the parentheses and hit Shift Tab, so that's Shift and Tab, you get back help on the function or the object. And here it tells us that this is returning a copy of the string converted to uppercase. So that's great. We're getting back Python in uppercase. An important word that's easy to skip is that this is a copy. So if I look at Word now, it has not changed. Word.upper gave me a copy of Python in uppercase. Word is still in lowercase. That's really important because in Python, strings are what's called immutable. You cannot change a string in place. You can overwrite it. You can, change it. Replace it. But any method that you have, or any function that you have on a string, will return a copy to you. Now there are plenty other methods available. If I don't do Shift Tab, if I type my object, I hit dot and then hit tab, I get this little pop-up menu that shows me all the methods attributes available to me. So for example, I might check, is this a digit? And if I don't know how this works, then I do Shift Tab, and this returns true if the string is a digit string, false otherwise. And you notice that you need parentheses to run it, to call it. And so this is not a digit, right? These are letters. So that gives me back a Boolean. Okay, so let me go to another type in Python, which is a list. And here I've got a new name, word list, and I'm just passing, instead of a single value, so Python, I'm now passing multiple strings, comma separated inside of square brackets. Now, if I run this, again, there's no output, right? Now, if I do what I did every time, so if I check the type of word list here, I see it's a list, so that's a Python type, just like string, float, bool, all of the others that we've seen. And as before, we can check the len of word list. So we have 5 values in there: Python, geology, programming, code, and outcrop. I can look at word list and get back the object. Something you can do here that you can actually do with strings as well is check for membership. So for example, I could say, well, tell me if geology is in word list. And in here, this checks for membership. And this returns to me a Boolean value. So yes, geology is in the word list. However, I just want to draw your attention to the fact that geology with a capital G is not in word list because Python is case sensitive. Now, just like with strings, we have methods available to us. So as before, I can do dot and hit tab and look at the methods. So the first one we see there, append, is very common. And if I check its documentation, it tells me that we append an object to the end of the list. And so I might add, I don't know, mineral. And if I run that, I don't get any output. So it's a bit like an assignment. But if I now look at word list, indeed, I've added one value to the end of it. Okay, now if we've created these lists and strings, very often we're going to want to reach into them and grab one or several items out of them. So how do we do that? Well, we do that with what's called indexing and slicing. Indexing is if you want a single value, and slicing is if you want multiple values. Now, there's a couple of things to remember when we're dealing with indexing and slicing in Python, and this applies not just to lists or strings, or it applies to everything really, is we start counting at 0. And for indexing and slicing, we're going to be using square brackets. So let's start with a string. So remember we had word, that was Python. And remember that that had a length of 6. So how do we index into that? Well, as I mentioned, we use square brackets. If I want the first value, so p for example, I can pass 0 in my first brackets, in my square brackets, and I get back p. Now, if I want the n, I can say give me the index 5. Now notice the index n, right, or the index 5 for n is 5, so it's 1 less than the length of the word because we start counting at 0. So if you were to index or to reach in at index 6, you'll get an index error. These are very common, and in general it just means that you're reaching, you're off by 1. You're reaching outside of the list or the object. So that's it, how we can get a single value out of a list, and or in this case a string. It's the same with a list, as we'll see shortly. If we want to grab multiple values out of an object, we use 2 numbers, and this will give us a slice. So for example, I can say go from 0, and then I use colon and go up to 3. And this gives me the first 3 characters, P, Y, T. However, if you just look at what we're counting, so we're going 0, 1, 2. So we're not actually grabbing the value at index 3. So this interval is a half-open interval, right? So we include 0, we exclude 3. That's something that you need to be aware of. And you'll see this quite often, well, all the time, really, in Python. So I'll keep talking about indexing and slicing, but now we'll use a list instead. It's the same principles, but we're just changing the object that we're targeting. So if I go back to my word list, I've got all of this. No surprises there. I can do the same thing as I did just a second ago, grab the first one. Now, if I wanted to grab the last one, and I don't know how many there are, I told you that you get the value that's 1 less than the length of the object. So you might do something like this, where you say len of word list minus 1, and that indeed gives us mineral. But this is way too long, and so what people writing Python do is you just say word list minus 1, and what this does is it will start counting at the back of the list. So you start counting 0, 1, 2, 3, 4, etc. And you go from the back, minus 1, minus 2, minus 3, minus 4, etc. Now, if you wanted to grab an interval that includes the last value, because I told you that the last value that you put into an interval is not used, what you need to do is you need to omit it. So how does that look? Well, if I wanted to go from index 4 to the end, I say 4 colon. and that gives me outcrop and mineral. So 0, 1, 2, 3, 4, and the last one. And you need the colon because if you don't have the colon and you just say index 4, you get a single value, you don't get a slice. Okay. So now we're looking at another type in Python, a dictionary. So this is a container, or you can think of it as a container. And so here I'm giving it the name container and I'm creating it. You see the syntax is a little more complicated than what we've seen so far. We've got curly brackets, and then essentially we have key value pairs. So the key is, in this case, a string. The key can be anything that's immutable. So we've mentioned strings are immutable, so they're good candidates. And the value on the other side of the colon is anything you want. So I'm using word list, word, and a value here of 2022. So if I execute this cell, I get back a dictionary. And as before, if I do type of container, I get back that this is a dict in Python. So no big surprises there. Now we can look at the methods available to us here. If I do .tab, so I'll start with keys, for example. If I execute this, we see that we get back words, word, and transform. So these are the keys, words, word, and transform, that are holding the values in the dictionary. Now, I talk about values, so let's look at those. The values are this first list that contains everything in words. The second value is Python, and the third value is 2022. Now, I'm not going to go into details of dictionaries. Suffice to say that we don't use square brackets to reach into them. Well, we can, but a method that is very common is to use, for example, the get method. And you can say, get the value inside of this container whose key is word, and that value is Python, right? Because word was Python. So remember that word is Python. So because I put word in there, I get back Python. Okay, now dictionaries are a massive topic on their own. I won't go through all the details here, but you'll see them in, no doubt, all of the tutorials. So it's important that you at least understand that they're containers of data, and you don't access data in them in the same way that you access data in strings or lists. Now, so far we've just used pure Python. So I didn't have to add any additional packages or libraries or modules. It's just been pure Python. Now, how do we add more functions or more functionality? So sometimes you need to reach for something that's not loaded by default. And there are three main ways to do that. You can import the whole package. You can import the whole package with an alias, and then you'll access things with name of alias dot function. Or you can say from package import function 1, function 2, and then you just have those names. So here what we're going to do is we're going to illustrate that by importing from datetime this function called datetime. And it's not the best name for them, but I want to illustrate what we can do with it. So what we're going to do is add today's date to the dictionary. So to do that, I can go to datetime and I can say datetime now. And if I execute this, I get back on my particular computer at my locale the exact time right now. Now what I can say is just give me the date. I don't want the time, I just want the date. So now I've got 25th of April 2022. And perhaps I want to change that format into something that's more standard. So I can say .iso format. And then I get back a string. Remember that anything in quotes in Python is a string. So I get back a string with today's date. So if I wanted to update my container, remember I've got this container here. I can say container.update. And then in there, I can pass a dictionary where I might say, for example, location is global because transform is global. And I might say date is, and then here I can say all of this. Now, if I run that, and then I look at the container, you see that we've added location, it's global, and we've added a date, today's date. And if I reach in now, I told you about the get method. You can use square brackets to get something out of a dictionary as long as you know the name of the key. And if you do that, you'll get back today's date. Now, do beware that if you have a typo in your key, you'll get a key error. Okay, so keying into a dictionary, let's have a look at that quickly. If we do container.keys to see what keys are available to us. So just as a recap, I can do container.get, I don't know, location, for example, or container square brackets date. But do beware that if you've got a typo in the date, you get an error. If you've got a typo in the get method, so if I do .get ASD, I get no errors. So I don't get this key error that I got above. I just don't get anything back. Now, if I want, I could actually pass a value here and say, I don't know, this key does not exist. And then I would get back that string. So again, square brackets are absolutely fine if you're 100% sure you've got the correct key. If you're not sure, use a get method as it's safer. Okay, so now let's change gears and look at controlling the flow in our Python code. So we often want to make decisions based on code, and for that we need Boolean values. So we've seen these before, things like, x is greater than 5, or I don't know, word is equal to Python, or something like global is in container.values. So all these things give me back a Boolean, and it doesn't matter what kind of thing you're using as long as you get back a Boolean. And now I can use this in a basic if statement. So I might say something like, for example, if word is equal to Python, colon, and then enter. And this is where, for the first time, we're seeing the importance of essentially indentation and white space in Python. So all the white space that I was using with operators is really just to make it more legible. But this white space here, which is 1, 2, 3, 4 spaces, you need that for this to work. So in an if statement, I say if, and then I have a condition that returns a Boolean, followed by a colon. And on the next line, indented by 4 spaces, I'll have whatever action I want to take. So I might say print code. And so here, for example, because word is equal to Python, this statement does get executed. So let's look at container.values again. And we've seen that we can check membership. So this is just repetition of something that we've seen earlier. So now we can use this in our conditional statement. So, or this kind of thing. So I can say if Python in container values print code, otherwise print no code. So in this is greater or equal to 0.3, then I'll say reservoir is equal to good. Then I can have elif, which is going to be else if let's say 0.15 is smaller than porosity, and that is smaller than 0.3. So you see how we can chain these conditionals. Here I could say reservoir is medium, for example. And finally, I can have an else where I say reservoir is poor. If I now look at reservoir, given that I've chosen a porosity value of 23, this returns medium, as I'd expect. Now, this construct, we'll see this all over, and it's not always an if, else. You could have multiple if statements without an else, and in that case, every if statement that returns true will be executed. It really depends on your particular use case. So now what I want to look at with all of these things that we've learned so far, we've seen so far, is looping in Python, so repeating ourselves. And one of the main advantages of computers is the ability to repeat these tedious tasks where we would make mistakes for sure. So first I'm going to load some data, and for that I'm using NumPy. And as I pointed out earlier, there are ways, standard ways to import these things. So you should always import NumPy with an alias, which is np. If you run this, or when I run this, there's no errors, there's no output. That's because NumPy is inside of my environment. In my environment.yaml, remember we had NumPy, so that means I can do this. And then I'm grabbing some data from the data folder inside of this repository. And I'm going to do a couple of things. First, I'm going to print the shape of those data. So how many rows and columns we might have, those kinds of things. And then I'll say that n-phi is just going to be this, all the rows and this column 1, and print the shape of that. So you see that we have 4 columns, gamma ray, n-phi, rho b, and dt, and 71 rows. And when I grab n-phi, I'm grabbing all the rows. That's what this colon is. And we've not seen this before, but when we're in NumPy and we have multiple dimensions, you do indexing and slicing exactly like you do in strings and lists. However, you have a comma between each dimension. Now, we don't need to put all the other dimensions because we're not doing anything with them. So now if I look at n-phi, we have 71 values of porosity in this case. So what can we do with this? Well, let's look at a loop. How do we loop over this? Well, let's say well, first of all, let me show you that poro does not exist. So poro, I get a name error because name poro is not defined. Now what I can do, I can say for poro in n-phi, for example, and I'll only use the first 5 n-phi values. I don't want to use all 71 of them. Then I can say print poro. And so here you see that one line after the other, we're printing each value in the n-phi. Now it's worth just pointing out that up here, we've only got 4 decimal places, whereas down here we've got the full precision. That's simply how NumPy is displaying data. The data under the hood are exactly the same. They're just being displayed slightly differently. So now let's look, let me delete these cells. Let's look at a few lines of code and I'll run them and then we'll talk about what we're looking at here. So we're importing a new library, matplotlib, which I mentioned. This allows us to make simple plots quite quickly and quite easily. I will say that matplotlib can become quite verbose, but you know it's really good for quick and quick data exploration. So the first thing we're doing here is we're creating a plot with n-phi. That's giving me this blue line. Then we're adding these 2 horizontal lines, 2 red lines, 24 and 22%. We're adding a couple of labels and we're adding a grid in the background with an opacity of 40%. And so that gives me this nice little plot here that's relatively easy to make. So So there's a few more things I want to show you before we go down here. So remember I'm going to copy this over because I don't want to retype all of this. Remember we had this porosity with an if, elif, else statement. Well, what I can do now is I can combine this with my loop. So I can say for poro in n5, I'll just do the first 5 again. And I can grab this code and paste it in here. I just need to make sure that everything is indented correctly. And then at the end, I can add a statement where I say print reservoir. And then we find that all of these are medium value or medium porosity or medium reservoir quality in this particular case. Now, what we could do is we could start counting these. So I might do something like good reservoir count is equal to 0, for example. And then for poro in n5, let's grab the first 10 here. And by the way, I'm just using the first 5, the first 10 while I'm prototyping. And then when I'm happy with my code, I can run it on everything. So for porosity or for poro in n5 10, I can say if poro is greater or equal to 0.24, for example, then say good reservoir plus equal 1. So what does this plus equal mean? Another way to write that would be to say good reservoir is equal to good reservoir plus 1. But this is too long to write. So instead of that, we can, the hashtag here is a comment. So that means that this line of code 6 will not be executed. So instead of running this, I can simplify that. And instead of having item equals item plus 1, you can do item plus equal 1 and you get the same result. And at the end, if I look at good reservoir count, we see that in these 10 first values, we've got 7 that are good with this particular cutoff. Okay, now if I run this same code with everything, so without filtering out, I can see that in fact I have 20 rocks of good quality. And this process of building up your code on a small sample is something that I'd recommend so that you're not running your tests or your prototyping on very large data sets straight out of the gate. Now, I will just show you that you can do this with one line of code, essentially. And I'm showing you this really just in case you see it somewhere else. So there's a structure called a list comprehension. And so what you can do is I could say, for example, 1 for poro in n5 if poro is greater than 0.24, and then I could sum that. And if I look at good reservoir LC, you see we get the same result as with this loop. That's because we're doing the same thing here on this one line. Now, I will say that this is something that beginners really should not be concerned about. However, if you see this kind of thing, you should know that this is nothing more than a loop. So there's 1 for poro. If you see that, that's a loop. And then everything else that's going on there, you can basically do like this. But you'll see both of these. So I think it's useful to at least have seen it once. Okay, so I'm watching the clock here as well. So I'm going to go back into matplotlib. So the Python visualization landscape, there's a link over here to Rougier's, I can't remember his name, Nicolas Rougier, to his repo here. And the Python visualization landscape, as he illustrates here, is very broad. We're only talking about matplotlib over here. If you want more interactivity, there are some little tricks that you can do. I'll show you something in the notebook in a few minutes. But if you want really fancy, powerful interactivity, you're going to have to go towards D3.js, JavaScript, and so on and so forth. But, you know, for most data science and data exploration, you'll be more than happy with Matplotlib and some of the associated libraries here. So it's worth noting that, as I showed you in a few cells above, you can write your own code here, your own plotting code. But a really good place to go is to go to the Matplotlib library, to their examples, and you can access those directly from the Jupyter Notebook if you go to Help and go to the Matplotlib reference. Okay, looks like they have to update that. If we go to matplotlib.org, looks like I've got a broken link, or there's a broken link in the reference there. But if you go to matplotlib.org and then go to examples, you see that there's a large collection of pre-written plots that you can choose from. And I don't know, if you wanted something like a scatter plot with histograms, if you click on there, you then have basically the code that you need to create that plot. So let me illustrate that. If I was to copy this to clipboard, come back here, and then make a new cell and paste that in there. Oh, hold on. I need this code as well. I need more than just the function. And there you go. Now I have the same plot as I did in the documentation. And without knowing anything about Python, you can still come back and have a read of this. And really what you want to change is you want to change XY to be your data. You don't need to worry about all of this if you're just wanting to plot X versus Y with this kind of output. So in general, I'd recommend starting from the library, starting from the gallery, and modifying your code to match what you're aiming for. So let's go back to our simple example. So again, I'm just reiterating these imports so that you see them. You absolutely don't need to do them more than once, but I think it's useful to just see it over and over again. And we've seen that we can do simple plots like this, plt.plot of n5, for example. N5 is not a string, sorry. Data n5, not n5 the string. Now, you can start to embellish this plot a little bit if you say plt.plot of n5, and then we pass additional arguments. So for example, I can say I want O dash, I'll show you what that is in a second. I can say C is equal to G, like this, and now you see that the O dash is giving us these circles at the data points. C is the color of the line, G stands for green, no surprises, hopefully. Now, all of this is fine, but it's what's called declarative plotting. So when we do plt.plot, and here I could say plt.grid alpha equals 0.4, plt.label, plt.x-axis label, and so on and so forth. There's another way to use Matplotlib, which is much more robust, and you'll see in the documentation. And that follows this pattern, where we'll say fig, ax equals plt.subplots, for example. This will set up a figure and an ax in Matplotlib. So the figure is basically the canvas that we're drawing on, and each ax is going to be one plot. So when you see plots with, for example, in the installation markdown, I showed you logs and a map and a cross-section. That's one figure with 3 axes in it. So now what we can do is we can say the same kind of thing as we did with plt.plot. I can say ax.plot of n5 with the same kind of thing here. I might say the line width, I want that to be 4. I might want the marker size to be 2. So if I run this, let's see what I have. N5. Oh, not 4, 0.4. I was looking a bit too thick. There we go. Line width of 0.4, marker size of 2, so it's just slightly thinner than what we had here. You might want to do ax.set y label. Now we do need quotes because this is a string. Ax.set x label, and this is just the sample number, for example. Ax.set title, and this might be simple porosity plot. And again, I might set a grid. So ax.grid with an alpha. Again, the alpha is the opacity of the grid. And so now with just a few lines of code, I've got a plot that's slightly nicer. And of course, I could save this to disk if I wanted to, which I'll show you in the next cell. So now we've created the plot. I want to pull everything in the same cell. So you see that with fewer than 20 lines of code, if I run this, I import NumPy, I import matplotlib, I load some data, I grab or I reach into that data and get only the N5, but if you wanted, you could do row B, DT, or whatever. I create a plot with all the labels and axes that we've seen so far. And finally, I save a figure. So if I go back over here to images, see that a second ago I saved n5.plot png, which is our little PNG plot here, which you could then include in an email, a document, anywhere you wanted. So hopefully that illustrates what we can do with not that much code. Okay. So now I'm going to show you another cell where we've got some interactivity. So, well, let me just stop here before I show you all the code. So we can add some interactivity using IPy widgets, and the documentation there is pretty complete, well, very good actually. And it'll show you how you can add these widgets. So sliders of different types, range sliders, progress bars, text boxes, and so on and so forth. And so what I've got down here, I know it's quite a lot of code, so let me run that first. I'll show you what it does, and then I'll explain the code. So we've got the same plot as we had before, but now we're coloring things based on which window they fall in. And we've got these little sliders here where we can say, well, actually, I want to extend the range of what's medium. So I now only have one high value, perhaps that's too high. Perhaps I want to be down here. And likewise, I can change my lower bound. And you notice that the markers are updating. The markers are changing depending on which family they fall in. The colors changing. All kinds of things are changing. So how do we do this? Well, you see there's not that much more new code relative to what you've seen so far. So these two lines are additional. We need them to add the widgets that we've got here. This is brand new. You've not seen this before. And in fact, this structure is new as well. We'll talk about that shortly. But essentially what we're doing here is we're saying we want to have these different float sliders available to us. And then we pass the values given by the user into our plotting code. Now, don't worry too much for now about what's going on here. But the plotting code is essentially the same as we've seen. So figax, n5. Here there's some Boolean values. This is a little complicated, and I'm not going to explain this now. But essentially what we're saying is that if the value that we've got is greater than high, then we're going to pass this particular up arrow. We'll change the color to red and so on and so forth. So that's what those things are. The fill between, that's what's giving us this green fill down here. And then everything else is stuff we've seen already. The only new thing is ax.legend, which gives us this legend over here. Okay, the legend we're getting because we've got labels. So that's what's being passed in. So we've got label high and label low. And so that's why we see these here. Now, I appreciate this is way too much code for someone who's never coded in Python, But what I want to illustrate is that with less than 30 lines of code, you can have a nice little interactive plot where you can test things and visualize things. Now, as I said, if you want more complex visualization tools in Python, you're going to need to essentially go towards JavaScript. Okay, so the beauty of code is you can reuse it. Now, we've used functions already. We've just seen one, in fact, just above. But let's have a look, first of all, at print. So the type of print is a built-in function or method. We saw sum once, and the sum you can actually pass what's called an iterable. So you can pass a collection or a sequence, and you'll return basically the sum of it. So we've seen that. We've seen plt.scatter. So I don't know, plt. Well, let me show you, for example. If I've got a bunch of x's, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I say x squared is going to be, well, I'll use a list comprehension here. Remember, this is just a loop. If I say x squared for x in x's, then maybe I'll look at x2 here. So you see we've got the square values of x's. Well, then I can do plt.scatter. This is also a function. I can say, give me x's versus x squared in red, for example. So this is also a function that we're using, and we're passing different values to it. Now we can write our own simple functions. So for example, I can say I want to create my adder that's going to add 2 numbers. To do that, we use the keyword def that you've seen once before in that interactive plot. And then I can say my adder. This is the name of the function, and it's important to note 3 things. It starts with a lowercase letter, and it has a lowercase character. It has to be a letter, and there are no spaces in the name. So that's why we've got an underscore there. Then after the name of the function, we'll have parentheses, and inside the parentheses, we have the arguments or the parameters of the function. So here I might just have a and b. I have a colon, and in Python, every time you have a colon, you have an indented block. So that looks like this. And then I'll have a docstring, and I'll show you why we need that. So a docstring is going to be a string enclosed in 3 single or double quotes. That simply allows me to have multi-line strings. So I can say add 2 numbers, and then I can say args, I don't know, a, b, like values to be summed, and then returns sum of a and b. Something like this. I'll show you why we're writing that. And then I can say return a plus b. Now, if I execute this cell, I'm defining, that's the def keyword, so I'm defining this function. So now I can do the shift tab trick that you saw before, or you can pass a question mark, and that immediately gives you a little pop-up window at the bottom of the screen, and you see that we've got the little documentation that we wrote here. So that's something that you should always do when you're writing your own functions, to make sure that you've documented what it takes and how it works. Okay, so now we can actually use it. So I can say my adder and add two values, and you get back the result that you wanted. So that's the basic syntax. Now I just want to show you how we'd write an actual function in Python. So you may remember this equation from the start, so the Gardner relation. So if you wanted to write this, we'd say Gardner, and here we actually want VP. However, we want alpha and beta to be parameters that the user can change. So I'm going to jump ahead a little bit here, but what we can do is we can say alpha is equal to 310 and beta is equal to 0.25, colon, and then I need a doc string. So I'm going to grab that from another screen so you don't watch me typing all this stuff. So here we're evaluating Gardner's relation. The arguments we have are VP, which is a float, p wave velocity. Alpha and beta are float-like, so they can be ints or floats. Alpha is the scalar and beta is the exponent. And we return rho as a float, which is the density. And I've also added a source over here to the subsurface wiki, which I recommend you check out. And so then what we can do is we can say return alpha times VP to the power of beta. If I now execute, if I call this cell, I get back a value that I would expect. So writing functions is something that you should always do in Python once you've prototyped. And hopefully what I've shown you in this little quick tour of Python is how you can take the syntax of Python, basically build it up into conditional testing, into loops, so to reiterate or to repeat code. You can make plots. You can write functions that then you can add interactivity to if you're plotting. And you can reuse those functions in all kinds of places in Python. So coming to a close in this little intro, I just want to point you to a few places where you might want to go next. Useful and approachable documentation. There are 3 main places I'd suggest you go. Well, 4, I suppose. Python.org, there's a great tutorial section there. The Matplotlib gallery, which we touched upon, and w3schools/Python. The 4th place, of course, is Transform. So you're going to have this year a great series of tutorials, but there's also previous years where great introduction and advanced tutorials were made, and they're on YouTube for you to use. If you're more into books, I'd suggest these 3 books. So Crash Course in Python, Automate the Boring Stuff, and Learning Python. For cheat sheets, which I know a lot of people love, there's a bunch of links here which I'd recommend you check out. Pure Python cheat sheets, and then some more geoscience-focused cheat sheets that I'd strongly recommend. And then, of course, there's all the Transform YouTube tutorials. So there was a Preparing for Transform 2020 with setup guides for Windows and Linux, which we kind of covered today, but perhaps there was more detail there. There's a playlist of Learning Python for Geoscience available to you on YouTube through the Software Underground. And of course, there's all the content from Transform 2020 and Transform 2021. Now, the last point there is probably the most important in my mind, is your own awesome project. So the best way to learn anything is through practice. And so hopefully now you've got at least some illustration that with not much code, you can get some results that you can then share with others. So with that, I'm going to stop sharing and close out this little session here. I'd like to thank everyone who's watching this live, anyone who might be watching this in future. And for those of you who are watching live, I'm going to go into the related Slack channel to answer any questions you may have. Okay, thank you all.